Security resilience, protecting the integrity of the business amidst unpredictable change. We've certainly seen that over the last 2 years with COVID. Now, with cybersecurity, it's the strategy that helps drive towards prevention and risk reduction. It provides the ability to prevent data breach or reduce the risk of malicious intent. Impacts include service disruption. Now, we've seen this in the past in cloud service providers. We've also seen it in network service providers as well. This could be caused by distributed denial of service. We have things like reputational damage, and then huge fines from regulatory bodies. Now, cyber resilience is really the strategy that helps drive towards mitigating the impacts of both an adversarial attack and non-adversarial threats, such as human and programmatic errors. Now, mitigations here include continuously providing services during a service disruption. This could be a cloud service provider outage, successful ransomware attack, and really minimizing our exposure and to continue operating as normal with minimal impact. Now, organizations require both in order to secure and be resilient. Now, let's talk a little bit about one of the worst cyber attacks on critical infrastructure. Lots to be learned here, and that's the opportunity when you're building a cybersecurity resilience program, is that there is going to be this continuous opportunity of getting better. First and foremost, when you're going through a breach, it's difficult at best for anybody that's responding to that breach. And decisions are being made on the fly, even though there might be a lot of preparation up front that's made. Decisions are being made on the fly based on the potential impacts of such a breach. Colonial Pipeline fuels 45% of the American East Coast with gas, diesel, home heating, jet fuel, and military supplies. Now, it transports roughly 100 million gallons per day. When we peel back and look at this timeline, we see May 6, hackers steal about 100 gigs of data. And then they start locking systems. And this is things that we've seen in the past where the adversary will capture as much data as possible. And they could leverage that in extortion to force the hands of the victim to pay the ransomware. So this is nothing new. And usually the adversary will do all kinds of things first before ransomware is being leveraged. And why is that? Well, if the adversary starts with ransomware, and they may, but if they start with ransomware and there's other motivations there, then they've already showed that they're in the environment and the defenders and responders are in action, versus steal the data, move laterally, do the things that you can do, and then at the very last moment, maybe use ransomware to get additional payment. May 7th, the company proactively closes down operations. Now, this is the operational environment. And if I recall correctly, the adversary never made its way into the operational network. But May 7th, you only knew what you knew at the time. And the company made the decision, or one of the decisions, to shut down the pipeline to ensure the safety and integrity of that pipeline. They also froze down IT systems. Law enforcement got engaged. Cyber experts were brought in. And they had no intentions to pay ransomware. Now, May 8th, the US government assists in the attack response. There's allegations that hacker location was out of Russia. May 9th, the group called DarkSide named as the attackers. CISA and Transport Security Administration get involved. Biden administration is involved to bring the pipeline back online. That's a number one priority. And the company makes a statement about the safety and security of the pipeline, and as well getting it back online. Now, this must have been exhausting. We're only talking a few days in, but imagine having all of these third-party organizations now being engaged, all the way from CISA to Transport Security to the Biden administration and law enforcement, all helping trying to resolve the issue. But the pressures must have been massive for the folks on the floor dealing with this incident. May 10th, Biden does not directly implicate Russia. The company's statement made around remediation, so there's an ongoing and incremental approach to it. The FBI does confirm its DarkSide ransomware is responsible for the compromise, and they continue to work with the company and government partners on the investigation. May 11th, CISA and the FBI describe DarkSide and risk mitigation strategies. Company's website goes offline for a portion of the day. There's alternative fuel shipping strategies now in place, and they focus on safely bringing back the pipeline services. Now, May 12th, they start restarting the pipeline at 5 p.m., but the problem with any operational environment, for the most part, is it takes time to get fully operational. This will take several days to bring supply chains back to normal, and 2 weeks for gas from Texas to New Jersey, and 19 days for jet fuel that uses the same path. We have panic buying. More than 1,000 fuel stations run out of gas, and the company website is restored. May 13th reports that the company paid $5 million US in ransomware to the adversary or hackers. Even though this contradicts that previous statement. Again, I've always said this, you might take the position of not paying, but until you're in this situation, and you certainly want to prepare for this, you don't know what you might have to do to bring services back online. Again, the pressure certainly mounts here, especially somebody that's providing a critical service that has significant implications. June 7th, the US government had recovered majority of the millions paid to the adversary or hacker. So that's great news, but you certainly don't want to rely on that. And so, could you say there's an opportunity here? I would say every time that there's a breach, there's an opportunity to learn and become more resilient. And May 9th, to add salt to the injury, the Department of Transportation seeks $1 million in fines for services and safety violations. So you got to wonder the overall cost of this, right? Never mind the reputational damage, but the overall cost of a breach of this magnitude, right? When you're shutting down an operational environment and have to make that decision for safety reasons, and then, and end up with fines at the end of all of this. Certainly not an enjoyable experience, but certainly one that we can learn from. Now, the other thing that came out of this was the US government came out with an executive order on improving the nation's cybersecurity. And so there's a couple things here that are worth calling out. Removing barriers to sharing threat intelligence, modernizing federal government and cybersecurity. So this includes things like zero trust infrastructure, multi-factor authentication, data encryption, both rest and in transit. You have enhancing software supply chain security, and this includes software bill of materials. Now, we as an industry face this with Log4j, trying to understand where vulnerable pieces of code existed within the environment. Not an easy task if you don't have a way of tracking that software bill of materials, and that's something that we're starting to see more and more of. Establishing a cyber safety review board. You have standardizing federal government's playbooks and responding to cybersecurity vulnerabilities and incidents. We want to improve detection of cybersecurity vulnerabilities and incidents on federal government networks. The focus on prevention alone is not enough. First off, prevention will never be 100% effective, and therefore you need the ability to be able to detect and respond to threats as they're happening. And remember earlier I had mentioned the cybersecurity resilience includes both adversarial and non-adversarial type of exposures. So they call out specifically endpoint detection and response, and then improving the federal government's investigation and remediation capabilities, and then national security system. Now, the way you want to go into this is assuming breach. If you assume breach, or you assume things are going to fail, you can start bringing in the mitigating capabilities to be resilient. It could be as simple as if someone got ransomware on an endpoint, if they can't move laterally in the network and they can move to another device to continue operations, or even if they couldn't, we're only impacting one individual or a few individuals. We've certainly minimized the adversary's ability to broaden out that attack. So what's fueling this drive towards resilience? Well, there's all kinds of programs that exist out there, and there's many organizations really pushing this forward because of recent events. Now, financial resilience includes things like the integrity of the system. Operations resilience is the accessibility of these resources. Supply chain, we want to make sure that it's trustworthy. And then you've got organizational resilience, the dynamic nature of access. Hybrid work is an example, it's here to stay. And so the attack surface certainly broadens, but every one of these programs, if they're done independently and not with security in mind, they'll never be achieved. Security is the glue in everything that we do. Now, security resilience is really having the ability to protect the integrity of every aspect of the business. And the goal here is to withstand the unpredictable threats or changes that happen in the environment and emerge even stronger. So we want to confront the new world where everyone and everything is connected. And this is a real challenge for defenders, right? Because the attack surface continues to expand. Businesses are really working and operating as ecosystems. Supply chain's critically important. Their business partnerships are critically important. Any failure along any one of those lines, whether it's direct or indirect, impacts the organization. We're seeing an ever-expanding number of connections, and that's not going to change. We live in a connected world. We operate at digital speed. We want to share as much as possible. We want to be accessible. We want to know where our order is when we order food from our favorite restaurant. We want to know what street it is and how far it's away. We want real-time or near real-time access to data. Work patterns consistently shifting. So hybrid work, as I mentioned, is here to stay. And the risk is huge for both work from home or work from anywhere use cases. And so with this whole multi-IT environment reality that exists today, because we use SaaS-based services, because we've got cloud data centers and traditional data centers, private, hybrid, public, the complexity is massive. And so we move from data centers to cloud and SaaS. Now, it's interesting with cloud, a lot of organizations may start with a single cloud service provider, and then resiliency kicks in, and they might want to diversify. Or there's a competitive advantage to leverage a different cloud service provider. And therefore, organizations tend to start with one and very quickly learn that they end up with multiple cloud service provider, which increases complexity significantly. Cloud service providers natively provide more security out of the gate, but how do you provide the cybersecurity skill sets to support it while they all are maintained and operated differently? Then you've got your traditional wide area network. You move into software-defined WAN that has intelligence to understand the proper path that it should take to provide the resources needed. But you have risks such as direct internet access, and how do you secure that? You have agile to DevOps. You've got VMs to containers. Now think about the container side and DevOps. A lot of these services are coming up for a very short period of time. They come up because capacity is required, and then they slowly dissolve because the capacity is no longer required. And if that's a short period of time and the adversary was able to get onto that asset, get a foothold, and move laterally within the organization, and then that asset's been dissolved, it makes it very, very difficult for defenders and responders to understand exactly what might have taken place. And then you've got server/clients to more of this mobile access from any device, from anywhere. So the goal of focusing on resilience is really bringing those security concerns to the forefront. I said earlier, if you assume breach, you're going to be able to build more resilient security programs. And so you can start thinking of things like, what threats matter most to us right now? Where are we exposed, directly or indirectly? We have to think of both of these. Do we have visibility to detect them? Remember, this is SaaS, cloud, work from home, work from anywhere, cloud service providers, private, public, hybrid. Lots of complexity here. If breach, how fast can we recover? And how are we going to prove measurable progress? So these are some of the things you can start asking yourself while you're trying to drive towards a resilient security program. So it certainly requires more than what we've offered in the past. We really start shifting from point solutions to a platform-based offering that focuses on resilience. And so we go from prevention to detection, response, and recovery. Doesn't mean prevention goes away, but prevention is never going to be 100%. And so we want to make sure that we're investing in areas of detection, response, and recovery. We move from siloed to connected. So all of these security capabilities got to start coming together under that platform-based approach to help drive that resiliency across these disparate control points that exist throughout all these services that we're offering. And then you move from alert or threat-centric type approach, and then we move into context-centric. We want data. We want as much information as possible to truly understand, and we need to stitch this all together, right? We want to be able to see that it came in through email. It might have been a phishing attempt. The user clicked the link. It was from work from home. Then they access this cloud-based service. the asset had a vulnerability. It was exploited. It moved laterally across the cloud service provider network and moved into the other cloud service provider network, and then transitioned back into traditional private cloud that we've always operated in. And it was able to take this data, that data, or whatever, right? So a lot more context-based thinking here. All right, so what's the big deal in all of this? Well, let's talk about the complexity here. We have work from home, work from anywhere, branch, and main office. So we got public cloud, private cloud, and internet. From internet, we've got our SaaS-based services, a couple services here being shown. We've got private cloud and public cloud connectivity. And then we've got some cloud service providers that exist today. Now, I haven't even included the operational environment, but that would be one of the pieces that you would include here as well, because there's typically a tie-in between the operational environment and the business network. So let's go through this. Threat intelligence and response. We want to make sure that stretches across everything that we do. And then we want detection and response capabilities. So this includes things like observability, the understanding of the underlying infrastructure that it traverses and where the bottlenecks and issues might occur, because there could be an indication of something that's taking place, whether that be a threat or a service disruption. And again, this is going to help us be a little bit more resilient. We want to be able to prioritize, investigate, orchestrate, and automate, because we can't do this with just humans alone. All right, we have endpoint protection. And we have endpoint detection and response. You got things like sandboxing, the ability to understand everything that happens on the device if it were to be compromised. And that information is going to help fuel other defenses within the organization and truly understand what the adversary is up to. We want to extend that to our assets at home, anywhere, main office, branch office, all the way up into our cloud service providers. We also have internet-based controls that we could leverage. You got DNS and web proxy-based services. You got zero trust network access. You have cloud-delivered firewall, next-gen IPS, data loss prevention, and things like remote browser isolation. So the ability to offer a browser in a cloud that has no tie-in to the initial asset making the connection. And if the adversary was to try to compromise the browser, it's not actually compromising the endpoint itself. Next generation firewall, you may see that at the branch office, main office, your private cloud, as well as your cloud service providers. And that's going to provide things like next generation IPS, advanced malware protection, sandboxing, maybe even content-based control as well. Then you have cyber asset attack surface management and cloud security posture management. So now we want to gain visibility and understanding of our cloud security posture, especially across multi-cloud. We want to continually monitor the environments and detect any violations or misconfigurations. We want to fully understand the attack surface by mapping the relationships between the assets, like an S3 bucket and an EC2 instance that we believe is not publicly accessible, but maybe that EC2 instance is publicly accessible, and therefore there is a way to that S3 bucket through that EC2 instance. Maybe that puts us at risk. And we want to be able to quickly investigate and remediate any impacted assets. The goal here would be pinpointing blast radius. So this vulnerability risk will include assets that are within the branch, the main office, the devices that are work from home or work from anywhere, but also within the cloud service provider environment. And then we'd also want private cloud, but we want to understand the risk to the organization with these vulnerabilities. Vulnerabilities come out weekly. Do we have to patch 100% of everything? No. We need some intelligence to give us some guidance on what the real risk score of these vulnerabilities are, so we can prioritize and patch the critical ones that are going to impact our business. Secure workload. So now we're doing host-based controls on our workloads, and that's going to be in the private cloud as well as our cloud service provider. And you can start seeing the complexity coming together here, because if you started leveraging controls within the AWS environment in certain areas, and then you have an Azure cloud infrastructure that you've started to adopt, and you start using their security controls within their environment. And if you extend it beyond that, you can see that now it becomes very, very difficult. I need skill sets around all these different ways of controlling the environment, making it very, very difficult on my teams, never mind trying to integrate and pull this all together. Fragmentation in cybersecurity has always been a problem, and this only continues that theme when we're not looking at this holistically. Secure apps. So now we want to get closer to the application. We've seen some network-based controls, we've seen host-based controls, now we're looking at the application-based controls. And so we're really looking at cloud-native app development lifecycle from code to cloud. We want to drive security automation through the application development process. The goal here is to empower dev to assess and build security policies from the tools that they're using, such as Terraform and GitOps tooling. We want agentless Kubernetes-based deployment approach. We want real-time visibility and enforcement using an agentless approach with a single controller that offers simplified deployment without any trade-offs in the security controls that we're deploying. We want to make sure that we have visibility in that software supply chain. That's critically important so we understand vulnerabilities, where the software resides. We want to make sure that we have code signing, ensure the validity of the applications from build through runtime. And then we've got API security. We've got VPN. That's not going to go away. There's use cases still today. Even if you drive towards zero trust network access, there's still going to be remote access VPN needs. And you have your site-to-site VPNs, whether that come from the main office, the branch office, the private cloud to the public cloud. VPN is still going to exist. We've got cloud access security broker as we start moving into those SaaS-based services, understanding the applications, the risk levels. We've got things like shadow IT, malware. Now, we've mentioned endpoint protection, we've mentioned next-gen firewall, malware is embedded in all those technologies, but also you've got cloud-based services where you may want to run malware against those file repositories in the cloud, such as Box as an example, to see if there's malware that exists there and mitigate that risk. And then you've got email security, that number one threat vector that still exists. We've got network detection and response from the endpoint all the way to the branch and main office, to the private cloud, to our cloud service providers. We want to be able to understand all of the communication that takes place, to be able to determine whether or not the environment's operating as normal or if there is a subtle change to the behavior within the environment that may indicate a configuration, which may indicate a breach, or a configuration change with an unexpected outcome. And then we've got multi-factor authentication. These include things like remote access VPN, you've got private cloud applications, you've got SSH, you've got remote desktop, you've got your cloud service provider, you've got your server SaaS-based services, all leveraging multi-factor authentication. And there's some complexity here when you're running multiple multi-factor authentication platforms to solve that use case. And then we've got 802.1x, and we're driving a zero trust outcome within the campus environment. Before you connect, we want to posture, profile, understand the asset that's connecting, any deviations over time. We want to mitigate and remove the access that was granted based on their previous trust level. And we want to make sure that we're providing guest access at scale without increasing our overall risk. Then we've got DDoS and web application capabilities, DDoS scrubbing within the cloud. If a volumetric-based attack was taking place, shifting that to the cloud to have it scrubbed before it gets to the organization is critically important. And web application firewall, now we're understanding the web application, how it works, and we're building controls to mitigate our overall risk. And then decryption, right? You're going to have to decrypt everywhere. Here, whether that be private cloud, whether that be to the internet, whether that be in your cloud service provider, you're going to need to decrypt. The problem with that is the performance implications caused by decrypt, but you're going to need that as an example in your next-gen firewall. But there's opportunities here to drive that decryption capability out from the cloud. You also have the ability to do things like leverage telemetry from the environment to determine whether threats exist in the environment without having to decrypt it, and or shift that decryption to the SaaS-based service where you might be providing cloud-delivered firewall, DLP, next generation IPS as an example. And the human firewall. We want to make sure that we are leveraging the humans, which is the most important piece of all of this. And we want to make sure that we empower them with the information they need in order to make the right decision and minimize our overall risk. So imagine this in a multi-IT environment with a multi-vendor strategy. It increases complexity. It certainly puts pressure on our cybersecurity skill sets. It increases our overall costs, and it increases our overall risk. Now, I'm not suggesting you get one vendor to do everything in the entire security space, but you got to start partnering because the complexity is so high here. If you think it's hard to find security individuals to do certain things within an organization, the more fragmented this is, the harder it is. And not only that, now you get alert fatigue, you lose some operational efficiencies, and people just don't want to stay in environments that are mixed and complex. So we want to make sure that we're operating with precision. We want to make sure that we're leveraging the security skill sets that we have where appropriate and expand them as needed without introducing too much complexity. Now, what does it take to get here? Well, we see 5 dimensions of cybersecurity resilience. We want to activate those billions of signals. Now, we've just looked at a picture of all of those possible areas of opportunity when it comes to signaling. There's tons of signals that we're going to want to capture, but we want to make sure that we are using that telemetry that we're receiving across those billions of signals. And there's much more than that screen has shown. And having the ability to drive actionable outcomes from that intelligence. And we want to be able to take the right actions. We want risk-based contextual analysis. What does the risk mean to my organization and whether or not I need to mitigate this particular risk versus the other one that has just come up. And oh, wait, there's another one that just came up. I need to be able to prioritize that. I want to continually reevaluate trust. Just because I gave access to an asset when it initially connected to an environment or an application or service doesn't mean that trust exists forever. And if a disposition changes within that asset, then I want to change that trust level and maybe quarantine, disconnect, or reevaluate the overall access that asset should have. And we want to close gaps. And this needs to be pervasive. It needs to cover users, devices, network, applications, your cloud, your SaaS-based services. We need an open-based platform that pulls this together and allows that defensive capability to be systematic across all of these core areas of our environment. Get stronger every day. We want to continually to improve efficiency with orchestration, automation. Our ability to spring back faster is the ultimate goal. Now, some of the key characteristics are it integrates openly. It has a developer ecosystem. It's elastic. It scales up and down as needed. I don't have to worry about this platform, whether or not I'm going to run out of capacity. I want to be able to have global reach. I want it to be integrated across an ecosystem of capabilities that I've invested in. And again, threat intelligence at the top. We have detection and response. Then we've got user and device security. We've got things like identity and access, so multi-factor authentication or passwordless SSO. We've got zero trust. You got endpoint protection and detection and response. We have email security. The network security, we want firewalling capabilities, both enterprise, campus, and cloud. Remote access. We've got software-defined access to drive a zero trust outcome within the campus and wireless environments. Our services edge is going to provide things like DNS, web proxy, cloud-delivered firewall. You've got zero trust private access to the applications themselves. And again, digital experience becomes very, very important here. There's a lot of complexity under the hood, and we need visibility into that complexity and where issues might take place. It'll show 2 things. One thing is that you have just service disruption somewhere, and then how do you become more resilient? Well, maybe you choose a different path. The other side is service disruption somewhere along the path may indicate a security breach. And so it just gives you an early warning system to identify these risk areas. And then you've got cloud and application security. So we got workload protection where we drive zero trust outcomes with micro-segmentation, both cloud and the data center. You have cloud native security. This includes things like Kubernetes and container-based type security, and then application security with runtime application self-protection capabilities to secure those applications. Now let's go through a scenario here and how resiliency could be realized. And it could be as simple as this. You have ransomware on a victim's machine. Okay, that's gonna happen. Resiliency doesn't mean you're gonna have 100% prevention. In fact, resiliency means that you are assuming breach is going to take place and therefore minimize your exposure. So we've got ransomware. Now, what would normally happen is, in most cases, is that ransomware may try to move laterally, infect other systems that may have vulnerabilities that are on there. And there's lots of things you can do here to minimize that, right? You could just patch everything, make sure it's up to date. But that doesn't guarantee 100% prevention, because what if they're harvesting credentials off of the victim machine and using them to log into other hosts? There's all kinds of additional risk here. But what if they can't have access to other hosts? What if within that layer 2 segment, they can't move laterally? They can't communicate. Even though they're in the same broadcast domain, they can't move laterally. So right off the hop, I reduce my risk here significantly. But that victim will have access to workloads or services. And maybe 2 of those services, the ransomware that's on that victim's machine tries to expose an area within those workloads and just can't. Maybe the port's not open or the vulnerability doesn't exist, etc. But maybe it exposes one workload. Let's assume it does. Those workloads, and this is how an adversary will work, can also talk to and communicate with other workloads. And let's assume that it's got, an additional 5 workloads that it communicates with. Now that we're in the data center or the cloud service provider, there's an opportunity for that adversary to certainly move laterally to typically more critical systems with far-reaching impact than that initial victim. But again, we have host-based controls that removes the ability to move laterally. But let's assume one of the workloads allows that access that the adversary is trying to take advantage of. And we have a control within that workload that mitigates that risk. And you can see here that we're fairly resilient because we haven't impacted the entire organization. Yes, ransomware got in. That victim machine could be a virtual desktop that all we have to do is reimage, bring it back online. That workload could be a Kubernetes node, and we can just, kill it and bring up a new node. It could be that victim's machine needs to be wiped and reimaged, and they have a BYOD device that they can pivot to, or a corporate mobile device that they can pivot to, and access maybe their next meeting that's coming up. So again, this is resiliency in action. We're not going to provide 100% prevention. What we are going to do is minimize our exposure if a breach does take place. Now, the human element, as I mentioned, so I look at this 2 ways. Cybersecurity could be, for humans, would be an email looks odd, has an attachment, it looks too good to be true, it's got some spelling mistakes, I'm going to forward this off to the security team. And now they're part of the defensive capability. The other side is the humans play a role in resilience, right? So critical business meeting and the laptop is non-responsive, perhaps compromised. The user is educated and they know to shift either to the mobile device or their BYOD device and leverage that SaaS-based collaboration suite with security controls to deliver the content. They'll be able to connect to that meeting and operate as normal, as if nothing happened. And as that other asset that was compromised or non-responsive comes back online, it should be very seamless for the user to shift back to that asset and continue their meeting like nothing had happened. Partnerships are key. And so when we're looking at this, we want to make sure that the partners that you're leveraging are protecting data, systems, and networks. They have embedded controls and only enabled authorized use. Want to make sure that the privacy is maintained, fair, transparent, and accountable. We want to make sure that we know everything about where the data resides, who has access to it, and the details involved to ensure privacy. And we want trust. So strengthening resilience. Again, we have financial resilience, right? Ensure the integrity of the financial and data assets. We're going to do that with security. That's where security comes in to help support that. You have operations, understanding the risk of exposure, spring back from disruptions, limit the overall impact. We have supply chain. We want to protect the integrity, be able to withstand shocks. And then organizational resilience. We've got secure and hyper-distributed workforce constantly shifting. Again, security is pivotal in trying to drive towards those financial operations, supply chain, and organizational resiliency programs.